And question is that determine the following properties of moist air having dry bulb temperature of 50 degrees Celsius, having dry bulb temperature of 50 degrees Celsius and wet bulb temperature of 32.5 degrees Celsius, and the pressure is given as 180. Today we are discussing about the psychometric chart. What are the use and how to find the properties of other properties using the psychometric chart. Here we have two properties: dry bulb temperature dBT 50 degrees Celsius and wet bulb temperature 32.5 degrees Celsius. Then we need to find the following: these 8 properties. One is absolute humidity, molar humidity, percentage humidity, relative humidity, dew point temperature, humid volume, humid heat, enthalpy. Okay. This is the psychometric chart. This is only for pressure is equal to 180 m. For pressure above or below 180 m, these charts are not referred. So on the psychometric chart, the top side is percentage humidity and left percent humidity y dash absolute humidity kilogram water vapor per kilogram dry air, and VH volume meter cube per kilogram dry air, and temperature degrees Celsius on x-axis. Here we have two informations, two properties. One is we have dry bulb temperature as 50 degrees Celsius and wet bulb temperature as 32.5 degrees Celsius. Okay. Then we need to find the following parameters using the psychometric chart. First, absolute humidity. Absolute humidity. Absolute humidity. We have wet bulb temperature as 32.5 degrees Celsius. On x-axis, there is a temperature. There is temperature 32.5. Mark 32.5 degrees Celsius on x-axis. 32.5, 2.5, 2.5, 2.5, 32.5, 35, 37.5, 40. Then we have wet bulb temperature 32.5 degrees Celsius. Okay. That meet the 100% wet bulb temperature is completely touch the 100% humidity curve. Then these curved lines, these slope lines are called adiabatic saturation curve. Each line is represented here. These diagonal lines are the adiabatic saturation curve. Then from the point where the wet bulb temperature 32.5 degrees Celsius meets the that temperature meets the 100% humidity curve. That temperature is known as the wet bulb temperature. Then draw a line parallel to adiabatic saturation curve. Draw a line parallel to the adiabatic saturation curve like this. Then we have the DBT, dry bulb temperature. Dry bulb temperature is 50 degrees Celsius. The 50 degrees Celsius, draw vertically upwards. where the point meets the arrival temperature point meets the adiabatic saturation curve. Take left from that point. This is the point of our interest. Then from that point, we draw a line that meets the y-axis humidity, where the humidity y dash absolute humidity. Straight line, we get the absolute humidity as around 0.024. This is the 0.025 curve, 0.0 to 0.03. 10 divisions, this is the 0.024. 0.025 dash. The first answer of our question is absolute humidity y dash is equal to 0.025 kilogram of water per kilogram of dry air. Then moving to the second question, molar humidity. Molar humidity means moles of water per moles of dry air. So y dash absolute humidity is equal to y into absolute humidity is equal to y into molecular weight of water by molecular weight of dry air. Therefore y dash is our absolute humidity. We already know the value of y dash. Y is equal to y into 18 by 29. By rearranging, we get y is equal to 0.0366 kilomole of water per kilomole of dry air. So first two question is answered. First two question is answered. Absolute humidity, molar humidity. Then the third question is the percentage humidity. Going to psychrometric chart. Going to psychrometric chart. This is our point of interest. This is the point of interest. Here we can see that the percentage humidity, 2%, 5%, 10%, saturated humidity is 100, 80, 100%, 80%, 60%, 40, 30, 20. From the point of interest, we also draw a curve like this, like 30% and 20%. From the point of interest, we also draw like a curve like this, so around 28%. 30 is around 28%. So our answer for the third question, percentage humidity is equal to 28%. 28% humidity is equal to 28%. So we already find the three subpart questions: absolute humidity, molar humidity, percentage humidity. Then the fourth one is the relative humidity. Relative humidity, moving to the psychrometric chart. Relative humidity, we know the percentage humidity. By knowing percentage humidity, we can analytically find the value of relative humidity. How? Let me know. Relative humidity RH is equal to PA by PAS, partial pressure by vapor pressure into 100. We already know that the absolute molar humidity Y is equal to Pa by P minus Pa. We already find the Y value is equal to 0.3866 kilomole water vapor per kilomole dry air. We already find the value of Y as 0.0386 kilomole of water per kilomole of dry air. By using this relation, we can simply find partial pressure Pa is equal to 0.0377 bar. Then we get the partial pressure Pa as 0.0377 bar. Then we need to find the Pa as vapor pressure. The percentage humidity is equal to Y dash by Y S dash into 100. Y S dash means molar absolute saturation humidity is equal to 28%. By this equation, we can calculate Ys dash. Ys dash is equal to, we get Ys dash is equal to 0.08571 kilogram water per kilogram dry air. Then Ys dash, Y is equal to, Y dash is equal to Pa by P minus Pa into 18 by 29. Therefore, Ys dash is equal to, in terms of partial pressure, we write vapor pressure PAS by P minus PAS. Then we get the Ys dash as Ys dash is equal to 0.08571 kilogram water per kilogram dry air. From this, we can simply calculate the value of vapor pressure. Then relative humidity is equal to Pa by PAS into 100. We get the relative humidity is 13.67%. Then moving to fifth question. Moving to fifth question, dew point temperature. Moving to the psychrometric chart, dew point. This is our point of interest. Dew point means the point of interest. Take to right side of the psychrometric chart. This is our point of interest. From the point of interest, draw a horizontal line to meet horizontal line that meets the 100% humidity curve. Then draw downwards. We get the dew point temperature. Dew point 20, 22.5, 25, 27.5. So we get the dew point temperature as 27.5 degree Celsius. As of now, we answered absolute humidity, molar humidity, percentage humidity, relative humidity, dew point temperature. Then we need to find humid volume, humid heat enthalpy. Humid volume means VH. Humid volume VH is equal to 1 by 29. 29 is the molecular weight of air plus y dash. Y dash is our first question. Answer absolute humidity divided by 18. 18 means molecular weight of water into pressure. P is equal to 180. 180 is equal to 1.013 into 10 raised to 5. 10 raised to 5 Pascal divided by total pressure. Total pressure 1.013 into 10 raised to 5 into TD. TD means dry bulb temperature plus 273 and divided by 273. 273 is the reference temperature. Plus 273 we need to convert the degree Celsius to Kelvin into specific volume 22.4. So we get the 22.4. Specific volume is fixed for all the problems. So we have the dry bulb temperature as 50 degrees Celsius. Substitute in this equation, we get humid volume is equal to 0.949 meter cube per kilogram of dry air. Then the next question is humid heat CH. CH is equal to 1.005 plus 1.88 into y dash. CB plus CA into y dash. CB means the constant. That value is substituted here 1.005 plus 1.88 into y dash. Y dash absolute humidity is equal to 0.024. So we get the humid heat as 1.05 kilojoule per kilogram of dry air Kelvin. Then the last question is our enthalpy H dash. H dash is equal to CH. CH is our previous question. Answer humid heat into TD minus T reference. TD dry bulb temperature, T reference 0 degrees Celsius or 273 Kelvin plus Y dash is the absolute humidity into lambda. Lambda means latent heat of vaporization. Lambda is the latent heat of vaporization. Then the T reference is equal to 0 degrees Celsius. In substitute in this equation, we get the enthalpy as 112.5 112.5 kilojoule per kilogram of dry air. So from the two parameters, from the dry bulb temperature of 50 degrees Celsius and wet bulb temperature of 32.5 degrees Celsius, we answered the all eight properties of the psychrometric chart: absolute humidity, molar humidity, percentage humidity, relative humidity, dew point, humid volume, humid heat, and enthalpy. Then if the question is the dry bulb temperature and dew point temperature, we need to adjust we need to first find the point of inflection. Dew point temperature, go straight line, and then draw horizontal line to this point, and from this we get the humidity y dash. And dry bulb temperature, making a line from 50 degrees Celsius, then draw a vertical line that meets the dew point temperature line, absolute humidity line. That point is the point of interest. So from two parameters we can calculate all other parameters.